This is Bob Capetta from the College of the Florida Keys, and this lesson is on hyperbolas. So we're going to start with the following example. If I have x squared over 9 minus y squared over 16 equals 1. This is a hyperbola in standard form. X comes first, that's going to be important. We're looking at the 9 and the 16. So 9 is 3 squared, so rewriting this as x squared over 3 squared minus y squared 16, of course, is 4 squared equals 1. This tells me the span in the direction I have to go. Now, the center of this hyperbola is going to be at 0, 0. The span in x is 3, the span in y is 4. So what I'm going to do is I'm going to go 3 over in the x direction. I'm going to go 4 over in the y direction. And this is going to give us a box that we can use to identify the asymptotes for this hyperbola. So we're going to draw in that box. Over 3, up 4, from 0, 0. Now, the fact is, x comes first. So vertices will be on the horizontal part of this hyperbola. So I will have a vertex here and I will have a vertex here. So that is at 3, 0 and negative 3, 0. The asymptotes will be the diagonals of this box we drew. So starting at the center, up 4 and over 3, because y span is 4, x's span is 3. So up 4 over 3 over 3. This is asymptote this way. This is the asymptote the other way, up 4, back 3, up 4, back 3. Asymptote this way. Similarly, down 4 over 3. Asymptote this way. Now we can also find the focus. The rule for the focus for a hyperbola will be c squared is a squared plus b squared. So in this case, we will say c squared is 9 plus 16, which is 25. C squared is 25, so c is 5. So from the center, we go out 5 units to get the focus. From the center, 5 units, 1, 2, 3, 4, 5. Focus here, 1, 2, 3, 4, 5. Focus here. And then we're going to go ahead and draw our hyperbolas. Now you could certainly find other points on the hyperbola, but I think this is sufficient to go ahead and give us a reasonable idea of what this graph looks like. So starting at the vertex, heading towards the asymptotes. Gives us an idea of what that looks like. But again, I want to emphasize, x comes first, so the transverse axis is horizontal. Transverse axis is horizontal. The vertices will be on the horizontal part of the box, the horizontal midpoints. But let's go ahead and change that for our next example that will be vertical this time. So let's say y squared over 4 minus x squared over 25 equals 1. So let's graph this and do some analysis with it. So again, it's y squared over 2 squared minus x squared over 5 squared equals 1. This is the format that we want. So in the y direction, we're going to go up 2, down 2. In the x direction, we're going to go over 5, back 5. So our center here is still 0, 0. So knowing that our center is at 0, 0, y up 2, down 2, x over 5, back 5. So I'd like to draw in that box that will define our asymptotes as well as our vertices, our vertexes. So this time the transverse axis is vertical, y comes first, so that our vertices will be on the vertical part of this box. Vertex here and vertex here. So points on the hyperbola, what I like to call vertices, will be at 0, 2, 0, negative 2. Then we want to draw in the asymptotes, and let's think about the equation of the asymptote this time. So it goes up 2 over 5, up 2 over 5, looking like this. Down 2, back 5, down 2, back 5. So that is one of my asymptotes. So I think we can get the equation of that asymptote. The equation of this asymptote, the center is 0, 0, so that makes it easy. The y-intercept is 0, but we're rising 2, running 5. So one of my equations of the asymptotes is y equals 2/5, rise 2, run 5x. And the other equation you can see is this way, up 2, back 5. So down 2 over 5 is what we have here. So the equation of that asymptote would be y is negative 2/5 x. And I also like to get the two focuses, the foci. So we need to remember our rule there, which will be that c squared equals a squared plus b squared. So my numbers here are 4 and 25, so c squared is 4 plus 25, which is 29. So c is the square root of 29. Now the focus is going to be on the vertical part of the graph, since the transverse axis is vertical, since y comes first. So it'll be root 29 in the y direction, root 29 in the y direction. So my points, my two focuses, my foci, will be at 0, root 29 on the y-axis, and 0, negative root 29. Now root 29 is just a little bit more than 5, so I will go ahead and label my focus approximately a little bit more than 5, a little bit more than 5. And then we're going to go ahead and draw our hyperbolas, and they have to go around the asymptotes, engulf the asymptotes. So starting at the vertex, the distance, the difference of the distances is constant. That's what a hyperbola is. So we'll do a rough graph of this. If you want to get a better graph, you could, of course, pick a couple points on the that satisfy the equation. But this at least gives us an idea of how this is behaving. Would have been better heading towards the asymptote a little bit. Let's go ahead and do one more. This time we will move the center off of the origin. So if I have x minus 3 squared over 16 minus y plus 2 squared over 4 equals 1. The first thing we need to do is determine our center. So you can see what makes this thing behave like a 0, that would be x equals 3. What makes this behave like a 0, that would be y is negative 2. So the center here is 3, negative 2. So we'll label that in terms of our center. We need to see what our span is. What is our span in the x direction? What is our span in the y direction? So we have x minus 3 squared over 4 squared. So we're going to move 4 units in the x direction. 1, 2, 3, 4. 1, 2, 3, 4 to make our box. Minus y plus 2 squared over 2 squared. So we're going to move 2 units in the y direction. 1, 2 up, 1, 2 down equals 1. Our transverse axis is horizontal. X comes first. So my vertices will be here and here on the horizontal part of this graph. So let's go ahead and label those. Vertices where? At 7, negative 2. And it looks like we move 4 back from 3, so it looks like negative 1, negative 2. Now we can go ahead and draw in that box and consider the asymptotes. As well as the focuses, foci. So what do we have? In the case of our first asymptote, we are rising 2 and running 4. So my slope is up 2 over 4, or 1/2. And the point that it's going through is 3, negative 2. So to find one of my asymptotes, I have to find the equation of the line with that slope through that point. I like to use y equals mx plus b to do that. So let me go ahead and show you that process. So if I have y equals mx plus b, the y value is negative 2, the m value is 1/2, the x value is 3 plus b, negative 2 is 3/2 plus b, negative 2 minus 3/2 is b, which is negative 4/2 minus 3/2, which is negative 7/2. So if I have b is negative 7/2 and I have m is 1/2, I can put that together with y equals mx plus b. So if I have y equals mx plus b, y equals 1/2 x minus 7/2. So let's take a look at our picture, see if we can believe that. So we think one of our asymptotes is y equals 1/2 x minus 7/2. So again, starting here, rising 2, running 4, rising 2, running 4, down 2, back 4, down 2, back 4. Now, according to this, we're saying our y-intercept is negative 7/2, or negative 3.5, which sure looks like that's about where it is, at negative 3.5, so that reinforces our first guess. Now for our second asymptote, again, the slope is down 2 over 4, down 2 over 4, down 2 over 4. So for our second example, we'll say the slope is negative 1/2, and it's also through the center, 3, negative 2. So this time our slope is negative 1/2, still through the point 3, negative 2. We want to find the equation of that asymptote. So we will go with y equals mx plus b. Y, negative 2, is m, negative 1/2 of 3 plus b. Negative 2 is negative 3/2 plus b. Negative 2 plus 3/2 is b, so that's what, negative 4/2 plus 3/2, negative 1/2 is b. And our slope is negative 1/2 as well. So again, we think y equals mx plus b. So we get y equals negative 1/2 x plus negative 1/2, or minus 1/2. Seems to be the equation of the other asymptote. So we're going to draw that in and see if we believe that. So the second asymptote, y equals negative 1/2 x minus 1/2. So again, we can see from this point up 2 over 4, up 2 over 4, up 2 over 4. So we draw that in. Can we believe that the y-intercept is negative 1/2? Absolutely. That looks like that's where it is. So now what do we have? We have the two asymptotes drawn in. We have the equations of the asymptotes. We have the equations of the vertices. Let's go ahead now and find the focal points. So I have two foci. We've got to remember our equation for that is c squared equals a squared plus b squared. So c squared equals 16 plus 4. So c squared is 20. So c is the square root of 20. That's 4 times 5, so it's actually 2 root 5. Well, square root of 20 is somewhere between 4 and 5. So we've got to go 4 units away from the center in the horizontal direction, since that's our transverse axis. So somewhere between 4 and 5 units away from the center, 1, 2, 3, 4, and a little bit more. So you can see the focal point is pretty close to the vertex. Backwards, 1, 2, 3, 4, and a little bit more. So my focal point again is pretty close to the vertex. So let's draw our picture so we can see what it looks like. So it's heading towards the asymptote. From the vertex, heading towards the asymptote. From the vertex, heading towards the asymptote. Now what are those focal points? What are their names? How are we going to get there? Well, we are starting at the center point, 3, negative 2, and moving in the 2 root 5 direction, in the x direction. So my two foci will be starting at 3, moving over 2 root 5. So 3 plus 2 root 5, comma negative 2. And similarly going to the left, that would be 3 minus 2 root 5, comma negative 2. And that will conclude this lesson.